Hey grade 12s and 11s. So in this video, I'm going to show you two methods to solve for general solutions. Now, I'm not going to go in depth with these general solution questions. So I'm not really going to deal with situations where you can manipulate the trig equation to form the function of tan, for example, or the ones where we have trinomial factorization. I'm just dealing with the simple ones really, but I'm just showing you two methods of working with general solutions. So the reason I'm making this video is because I was working on the May to June 2024 grade 12 paper, and when I got to the trigonometry section, I see that we had to use general solution, but then I wanted to use a shorter method, but then I realized that not everybody may know this method. And so I'm going to show this method and of course the standard method in this video. So throughout these questions that we're going to work on the two methods. First, we're going to work on the standard method, the method that most students would use in class. And then we'll work on the method that I feel is actually much quicker. Okay, so the first method, the first equation that we're going to work on is you need to find the general solution for theta if sine of theta is equal to 1 over 2. Okay, so the first one is sine theta equals a half. So I'm going to deal with it using the standard method. So when we look at this normally, when we want to solve for theta, find the general solution for theta, what we would do is look at this number over here and ask ourselves whether it is positive or negative. So we can see that it's positive. And because it's positive, you think about your reduction diagram. And you really ask yourself, where is sine positive in your reduction? And sine is positive in the first quadrant where we just have theta, and in the second quadrant where we have 180 minus theta. And so you would use these as your solutions, okay, to find your solutions really. So to solve for theta, after figuring out what you're going to use, we would find the reference angle for theta. So that's like taking sine over, of course. So the reference angle would be equal to, when you take sine over, it becomes shift sine, or the inverse of sine, of a half. Okay, so when we do that, we're going to get 30 degrees. And so here is that standard method. We're using the reduction diagram. So our first solution for theta, right, this theta over here, we would say theta is equal to, since the first solution was just theta on its own, the answer would just be your reference angle, and then you would say plus k of the amount of degrees that it takes for a sine graph to repeat itself. And the sine graph takes 360 degrees to repeat. So you'll say k of 360 degrees. That would be your first solution. Then your second solution, you would say, well, theta is equal to, and you would use that because sine was positive. So you'd say 180 degrees minus, and the theta here represents your reference angle. So minus your reference angle, which is 30 degrees. And so 180 minus 30 is 150. And so that would be plus k of 360 degrees. And you need to, of course, tell them where k is an element of integers. And those would be your solutions for that. Okay, so how about let's try when this is negative? Okay, so using the standard method, or really the method that uses the reduction formulas, what we would do in this situation is we would still look for our reference angle. So when we're finding our reference angle this time, when you take sine over, we'll say that becomes the inverse of sine. But this time you're not going to say of negative a half. You still take the absolute value of that number over there. So we'll take of a half, right? And that will still give us 30 degrees. But here is where we will apply the fact that sine is negative. We will look at our quadrants and pick the quadrants where sine is negative. So sine is negative in the third quadrant and the fourth quadrant. In the third quadrant is where tan is positive, and the reduction there is 180 degrees plus theta. And here, this is where cos is positive, and the reduction is 360 degrees minus theta. So with that, because we're using these as our solutions, we're still trying to solve for theta. And so we would say that theta is equal to, and I need some space, I'm just going to move this here. So theta would be equal to, And we would just use these now to find our solutions, which is 180 degrees plus theta here represents our reference angle. So that's plus 30 degrees. And of course, 180 plus 30 is 210 degrees. And then you'd say plus k of 360 degrees because it takes the sine graph 360 degrees to repeat. And then would say or theta is equal to, and then you would use that. So that is 360 degrees minus 30 degrees, which is 330 degrees, and then plus k 360 degrees, of course, where k is an element of integers. And those would be your solutions. Okay, so here's where we use the quick method. So I want to show you how to use the quick method in both. So with the quick method, if we still have the same equation, sine theta being equal to a half, here's the rule with this. The rule is that as long as you're using the function of sine, you're only ever going to use two types of solutions. So to solve for theta, you're just going to say, first of all, theta is equal to your reference angle plus k 360 degrees. And the second solution will be where theta is equal to 180 degrees minus your reference angle, and then plus k 360 degrees. And of course, we will tell them that k is an element of integers. Regardless of whether this is positive or negative, you would always stick with this. So this is how it would work here. It worked just exactly the same way that one worked, okay? Because that was positive. So again, you'd find your reference angle to be 30 degrees, and then you just say theta is equal to that reference angle plus k 360 degrees, or theta is equal to 180 degrees minus your reference angle of 30 degrees, which gives you your 150 degrees, and then it is plus k 360 degrees, where k is an element of integers again, okay? And that will just be it. Now, what happens when it is negative? Because regardless of whether it's positive or negative, you have to do this. So here's the thing. When it's negative, if you have sine theta being equal to negative 1 over 2. So in this equation, in this method, using this method, when finding your reference angle, you take sine over, of course, to find it. But this time, you will consider that this is negative and you will use it like that. So that will be shift sine of negative a half, which would give you negative 30 degrees. And you're going to use it like that. So remember, with the quick method, or the method that I like to call the quick method, you're always going to use these two as your solution for sine, as long as the function you're using is sine. So we have theta is equal to, and we're going to use that, our reference angle, which is negative 30 degrees, then plus k of 360 degrees. We'll come back to that, and you'll see how it will still look like the solutions we have here. Or theta is equal to, and the second solution, remember, was this 180 minus your reference angle. So we would say 180 degrees minus our reference angle, which is negative 30 degrees. And of course, if we distribute, that becomes a plus 30 degrees. 180 plus 30 is 210. So we'll have 210 degrees there, then plus k of 360 degrees. And of course, tell them that k is an element of integers. Now, here's the thing. Generally, when angles are negative, if you want to make the angle positive, you just have to add 360 degrees to it. So that's what you would do here. You add 360 degrees to your negative angle, and this is what theta gives you. 360 minus 30 is 330 degrees, plus k 360 degrees. See how we still have the exact same solution using two methods. So that's why I call this method the easy method, because you don't really have to, or the quick method, because you don't really have to think about your quadrants. Now, we've just tried this method with sine, okay? Let's try it with an equation with cos of theta this time. So, using the standard method, with cos theta, when we're solving for this, again, we're going to look for our reference angle by taking cos over. If you say shift cos of root 3 over 2, you're going to get 30 degrees. And then you would consider that your function here is positive. So we're going to look for places on our reduction where cos is positive. And cos is positive in the first and the fourth quadrant. So we have theta there and 360 degrees minus theta. Meaning whatever we have as our reference angle, we just leave it like that. So we'll just have, when we're solving for theta, of course, we're saying that theta is equal to, and we have 30 degrees, and then you're just going to tell them plus k of the amount of degrees that it takes for the cos graph to repeat itself, which is 360 degrees as well. Or theta is equal to, and you would use that. So you say 360 degrees minus 30 degrees, and that gives you 330 degrees. And then plus k of 360 degrees, where k is an element of integers. And that will be your solutions, your general solutions, right? So when it is negative instead, we have cos of theta being equal to negative root 3 over 2. In this case, you're going to have to consider that your function is negative this time. Okay, and the places where cos is negative would be in the second quadrant and the third quadrant, right? Where we have 180 degrees minus theta and 180 degrees plus theta. So here you would just consider that since this is negative, when finding your reference angle, you don't have to find the negative of it. You just consider the absolute value. So that would be shift cos of root 3 over 2, which gives you 30 degrees though. Okay, and then you would just use those solutions. So theta again is equal to 180 degrees minus your reference angle, which is 30 degrees, or theta is equal to 180 degrees plus your reference angle. Okay, so there you get 150 degrees, then plus k 360 degrees, or here you will get theta is equal to, and 180 plus your reference angle will give you 210 degrees, then plus k of 360 degrees, and of course where k is an element of integers. Okay, so that's what you're going to get in those cases. Okay, how about we try this now for the second method? So again, we have cos theta, right, being equal to root 3 over 2. But let me actually just mention something here. So it's fine, we can just leave that equation. But the thing about the rule here, remember, we just have to follow rules. You just have to study these. For the sine function, these are your solutions for theta. But for the cos function, this is how it's going to work. The solution for theta for the cos function is very simple. This is all you need to remember. If you're trying to solve for theta or whatever angle you have to solve for, you're just going to say your reference angle, or you're really just saying positive and negative of whatever your reference angle is, and then plus k of 360 degrees because the cos graph repeats every 360 degrees, and where k is an element of integers. And that's all. So let me show you how it works with this. So we're just going to say, fine, let's go ahead, and we don't have to consider quadrants or where it's positive because it's a quick method we're using. So we're going to go ahead and find the reference angle. So the reference angle we can find by taking cos over. And we know that shift cos of root 3 over 2 gives us 30 degrees. Okay, so now that we have that, this is our solution. Our solution is where theta, since we're solving for theta, is equal to positive or negative of your reference angle plus k of 360 degrees, where k is an element of integers. So now you're probably wondering, but this doesn't look like this. Well, it can. So this is how we can actually make it look like that. It actually is the same thing. Just separate your solutions. So you see that you have a positive solution for theta. It's just 30 degrees plus k of 360 degrees. And we actually have that one, see? Then the negative one. So you just say, or theta is equal to negative 30 degrees plus k of 360 degrees. And I don't have to repeat that. I already said it once. Then when an angle is negative, what should you do? You need to just add 360 degrees to make it positive. So theta is equal to add 360 degrees. 360 minus 30 is 330 degrees. Then of course plus k of 360 degrees. And do you see now that we arrive at the exact same solution? You just have to think about changing that angle to positive. Okay, so that's how that works. And then if you had the same function, but this time our cos can be negative like we did here. Okay, so in this situation, remember we should still arrive at the same answer. So let's go. Let's use this method. In this case, we don't consider the quadrants. We just find our reference angle. So our reference angle, we'll find it by saying shift cos of that number. Don't even make it positive. You don't have to do that. If you say shift cos of negative root 3 over 2, you're going to get 150 degrees. So it means that theta is just equal to positive or negative of 150 degrees plus k of 360 degrees, where k is an element of integers. And then you can separate your solution. So it's either theta is equal to just positive 150 degrees plus k of 360 degrees, or theta is equal to negative 150 degrees plus k of 360 degrees. And then because your angle here is negative, you just make it positive by adding 360 degrees to your solution. So theta is equal to 360 minus 150 gives you 210 degrees. Okay, and we have plus k 360 degrees. And look at that. Look at our solutions there. We have the exact same solutions. Okay, let's try this for the function tan. Okay, so with tan, you actually start to see how tedious the first method is. So we have tan of theta, and with the first method, we would go ahead and consider the fact that this is positive. And so we need to look for the quadrants or the reductions where tan is positive. And that will be in the first and the third quadrant. So we have theta there, and here we have 180 plus theta. Okay, so with that being said, we're just going to use those. And now we have to find the reference angle of this. So if you take tan over and you find shift tan of square root of 3, it will give you your reference angle will be 60 degrees. So that means you would say theta is equal to 60 degrees. But then the thing about tan is tan repeats itself, the tan graph repeats itself every 180 degrees. And so it's plus k of 180 degrees. Or you would say theta is equal to 180 degrees plus 60 degrees. When you add those together, you get 240 degrees. So 240 degrees and then plus k of 180 degrees. And of course, this is where k is an element of integers. And these will be our solutions. So let's try this where tan has a negative value. So if we have tan of theta being equal to negative root 3. Okay, so now because it's negative, you have to consider that tan is negative in which quadrants? In the second and the fourth quadrant. And the reduction in the second quadrant is 180 minus theta. This is where sine is positive. And here where cos is positive, it's 360 degrees minus theta. Okay, so now that we have marked out where our solutions will fall under, we're going to go ahead and find our reference angle. So again, our reference angle, you're just going to take tan over, but you're going to say shift tan of the absolute value. So don't consider that it's negative. So shift tan of square root of 3, which again gives you 60 degrees. And so you would say that theta is finally equal to, and you would say your first solution is 180 minus theta. So 180 minus 60, which gives you 120. So 120 degrees. Then tan repeats itself every 180 degrees. So plus k of 180 degrees. And then or we'll say theta is equal to 360 degrees minus 60, which is 300 degrees plus k of 180 degrees. Of course, where k is an element of integers. So that will be our solution. So let's go ahead and try using the quick method now. Okay, so with the quick method, the rule that we use is very simple. If you have tan theta, all you're going to do is this. You're going to go ahead and solve. When you're solving for whatever your angle is, you're saying theta is equal to, you just say your reference angle plus k of 180 degrees, where k is an element of integers. Done. So if we're solving for this, we'd simply just say that we need to get our reference angle, and our reference angle will be found by taking tan over, and we say shift tan of the number that you have here. Regardless of whether it's positive or negative, you just take that whole number, okay? If it's positive, take it like that. If it's negative, take it like that. So again, our reference angle would just be 60 degrees. And so we'll just say theta is equal to 60 degrees plus k of 180 degrees, where k is an element of integers. And when we look at that, it's like, but where's this solution? Okay, so here's the thing about it. You see with the tan graph, and it's really just because of the nature of the tan graph. Remember that k is an element of integers, right? You see that if k is an element of integers, you can only substitute integer values into here. So let's go ahead and try that. I will just use a number line just so that we can see the solutions we're going to get. So we're going to try values like 0, +1, -1, and so on. If you substituted 0 into this, the integer value of 0, you see that 0 times 180 is 0, and so you just have 60 degrees. Okay, 60 degrees is one of our solutions, and you're going to have plus k of 180. So we're going to keep going every 180 degrees to find more solutions. In other words, we would either add by 180 or subtract by 180 to find any other solutions. So we get 60 degrees as a solution. But I'm going to show you that you can also get 240 degrees as a solution. And so it's kind of, you're just repeating the same thing by writing this one. Okay, if we substitute instead of 0, let's go ahead and substitute 1. So 1 times 180 is 180. 60 plus 180 gives you 240 degrees. You have the same thing here, then plus k of 180 degrees, meaning you're going to get the same solution. You're going to get a 60 degrees, you're going to get a 240 degrees, you're going to get what comes after that as well. And that's why you don't need to write the second one, because you're really just repeating yourself. Here's another reason why. If I show you based on what the tan graph looks like, and it's really just because of the nature of the tan graph and the way it looks. So if we compare a tan graph with something like a sine or a cos graph, the tan graph works like this. So with the tan graph, we're starting at 0, and we're going to have our first asymptote at 90 degrees. So you have an asymptote here at 90 degrees. And then remember, the tan graph repeats itself every 180 degrees, and so does every solution that it has. So if you have an asymptote at 90 degrees, your next asymptote is going to be 180 degrees later. So that's going to be at 270 degrees that you'll have your next asymptote. Okay, and then we can just end at 360. So the tan graph repeats itself every 180 degrees, meaning you will have one complete cycle within 180 degrees. So let's stop at 180 degrees here. And so the tan graph does this. It first shoots up, gets closer to the asymptote, but of course never touches it. Then it comes from the asymptote, being very close to it, but never touching. Right, so it's very close down there. And then it ends at 180 degrees. Then 180 degrees later, it does the same thing. It will shoot up like that again, and then come from the asymptote and end there. Okay, so that's the tan graph. And so the thing about finding the solution or the x value of root 3, you see 1 can be somewhere here. Root 3 is about 1.7, okay, 1.73. So it will be above 1. So that's root 3. See, if we had to look for the places on the tan graph where the y value is equal to the square root of 3, this is where that's going to happen. It first happens here, and that solution is at 60 degrees. Then, because of the nature of the tan graph, this same solution will repeat itself 180 degrees later, which is going to be, so as you can see, if we keep going, this is where the tan graph has a y value again of the square root of 3. And this happens at 240 degrees. So that's the reason why you don't have to repeat yourself here again. Because with the tan graph, you just need that solution. And then you need to say plus k of 180 degrees because it will keep repeating itself if you go towards the positive side of the x-axis and the negative side of the x-axis. Okay, so I hope that makes sense. So you don't really have to do all of this. We can also just go ahead and try out the negative value of this, the negative function when tan is equal to negative root 3, and work that out just because we're going to have a negative angle. Okay, so let's try using this method on this. So again, we don't have to really bother about finding which quadrants tan will be negative. We just have to find the reference angle. So our reference angle would be equal to taking tan over, and you're really just going to say shift tan of negative root 3. If you find shift tan of negative root 3, it's going to give you negative 60 degrees. So our reference angle is negative 60 degrees, and that's fine. Leave it like that. So our solution would just be this, and we're just going to say theta is equal to our reference angle, negative 60 degrees, and then plus k of 180 degrees, where k is an element of integers. Now, I know it doesn't look like this one, and that's fine, because the thing is that your angle here is just negative. When you find your solutions, you'll see that you would still get the angle 120 degrees at some point and 300 degrees at some point as well. So here's what I mean by that. You see, because the angle is negative, you could have just changed it to become positive by adding 360 degrees. And so that would be theta being equal to 360 minus 60 is 300 degrees. So we already have the 300. And then plus k of 180 degrees. And if you substituted integer values for k, you will see that one of your integer values will be 120. So let's go ahead and do that. If you substitute the integer value of negative 1, right, you would see that you'd get 120 degrees. So either way, this is still a correct solution, and you don't have to repeat yourself by putting both of them. And that is why I prefer using this method rather than this method. Now, I know this is not actually their names, and I'm only just doing this because here in South Africa, we use this method most of the time. But then I'm just trying to show you that there's actually a quicker method you can actually use. It just means that you have to study this, knowing what to use for sine, what to use in the case of cos, and what to use in the case of tan. Okay, I guess that sums it up for this video. Please comment down below the method that you prefer to use, and I will see you guys in the future videos.